In this video, we're going to derive the derivative of the cosine of x. So pretty much we're going to find the derivative of the cosine of x. So how do we find the derivative of this? Well, to find the derivative of anything, we could pretty much just say, just like the derivative of a function f of x. To find the derivative of this, we could just write it as a limit. We could say that it's just the limit as h approaches 0 of f of x plus h minus f of x all over h. So this right here is pretty much what a derivative would be as a limit. And so we could apply this idea to the cosine of x. And so the whole idea is that this right here would just be the limit as h approaches 0 of, and so what we're going to get, this is just going to be the cosine of x plus h minus the cosine of x all over h. And so that's the idea. And so all we really need to do is we need to figure out what this limit is. But how do we even figure out what this limit is going to be? Now, if we can't figure out a limit in the beginning, then let's just try some things that we already know. For example, we know another way that we can express the cosine of x plus h. That's just the cosine of two angles added together. And so pretty much there's an identity for it that we know. It's pretty much, we know that the limit as h approaches 0, what it's going to be is pretty much the cosine of x plus h. Another way that we can write that is it's the cosine of x times the cosine of h minus the sine of x times the sine of h, right? That's just another way we could write the cosine of x plus h. And then we just have minus cosine x. Oh, my bad. Cosine of x. So now that we have that, again, still all divided by h. So what can we do now? Well, notice how both of these terms right here, right, this term right here and this term, they both contain cosine of x. So we could just group those. So let's just try and group those terms together, right? So grouping these terms together, what we're going to get is, it's pretty much cosine of x, cosine of h, minus the cosine of x. And then we just have the rest of this, which is minus the sine of x, sine of h, over h. So this right here, we've now grouped these two terms together that both contains cosine of x. So the next thing we could do is we could actually factor out the cosine of x, right? So let's just do that now. So when we factor out the cosine of x, it's pretty much just going to be factoring out the cosine of x. When we factor that, we're going to get cosine of h minus 1. So cosine of h minus 1. And then we still have just minus sine x, sine h. Right? And all this is still divided by h. So now that we have this, notice how we could actually pretty much, let's just break this limit down into parts. We could say it's the limit, pretty much we could break this up into two terms where we could say it's this over h minus this over h. So pretty much the whole idea is we could say that this would be over h, and it's minus this over h, basically. We could, of course, do that, where we pretty much expand it out. Right, this minus sign, I'll just move it down to here. And we're taking the limit of this thing, right? So now, we could break this limit up into parts. We could say it's the limit of this minus the limit of this. And so I'm just going to write that over here, actually. So what we get is, it is equal to the limit as h approaches 0. And so for the first part, it's going to be this. So cosine of x times the cosine of h minus 1 all over h. So the limit of that minus the limit of this. Right, so limit of sine of x, sine of h all over h. So this would pretty much be what we're doing. It's the limit of this minus the limit of this. So this is what we're at now. So the next thing is, notice how we have cosine of x here and sine of x here. And the limit is as h approaches 0. Well, as h approaches 0, x isn't affected by that. So as a result, we could just bring cosine of x out in front of the limit, right? And same thing for sine of x. So what that's pretty much going to become is just the cosine of x, right? Cosine of x times the limit as h approaches 0, and it's going to be the limit of cosine of h minus 1 all over h, right? And the same thing here, we could bring out sine of x because as h approaches 0, x is not affected by that. So we could just bring sine of x out in front, where we get minus the sine of x times the limit as h approaches 0 of the sine of h over h. So this is where we're at now, all right? Now, pretty much we have two limits that we have to evaluate. But we already know what these limits are. Basically, what you need to know is that the value of this limit right here, oh wait, why am I using this color? The value of this limit is equal to 0, and the value of this limit is equal to 1. You pretty much have to know these in order to figure out the derivative of the cosine of x. And I actually made videos on pretty much showing that this limit is actually equal to 0 and that this limit is actually equal to 1. Right? I made videos on that. And so like if you're like lost about why this limit is equal to 0 or why this limit equals 1, I made videos and I'll put video links in the description to why these limits are what they are. Right? Anyways, pretty much this is cosine of x times 0. And this is minus the sine of x times 1. And since this is just 0, all we're going to be left with is the negative sine of x. So this right here would just be the negative sine of x. And that is the result we get for this limit. And so the derivative of the cosine of x is equal to the negative sine of x. So this is the whole idea of the derivative of the cosine of x. It is equal to the negative sine of x. And so yeah, that is pretty much it. That is it.